Welcome to the fifth and final video for using integration to solve indeterminate problems. In this final video, we will use this system of equations that we've managed to whittle down to only 3 by applying our boundary conditions as we go, and we'll use Gaussian elimination to determine what the reactions are at A and B and C. We'll find that they are 2.25 and 7.5. Now we're at the end. Right? We're very close to the end. We've got 3 equations left for us to solve. Right? We've got 3 equations left, and we've got 3 unknowns, AY, BY, and CY, the 3 reactions that we had. So it makes sense that we still have the 2 equilibrium equations that we started with, but now we've got this thing, and it looks hideous, right? But there's only AY and BY involved in that. Even so, I'm going to go ahead and use good old Gaussian elimination for this one. So let's start a table. Coefficient for AY. Coefficient for BY, coefficient for, well, that's not a C, CY, and the constant. So, for this first one, I'm going to name it A, like you do, and that's just going to be this first equation. So we've got 1 for AY, we've got 1 for BY, we've got 1 for CY, and then our constant is just going to be negative this term, which is already negative, so it's just going to be positive now. It's going to be positive 12 kips. And then for equation B, it's going to be this one. Coefficient for AY is, oh, that's convenient, 0. BY, it's going to be 6 feet, but we can just divide everything by feet, and the 0, and it's still 0. How about that? CY is going to be 12, and our constant is going to be 72. Again, it's already negative. So we'll just flip it to positive. Equation C, that's going to be this one. And that looks pretty ugly, but remember, hey, that's a constant, that's a constant, these are all constants. So all this is just going to all add together. What it's going to end up being is, I'm going to check my notes, 216A plus 36B plus 0C is going to be equal to 756. Cool. I'm actually going to do the Gaussian elimination because I think that some of you are not super clear on what that is. So let's look at equation D. Let's define D as, well, let's get rid of this. Is hideous, this equation C. Let's take equation C, and let's add equation A to it, times negative 216, right? So if we add that equation to this equation, negative 216 times, this goes to 0. This is going to go to negative 180, so that's okay. And this is negative 216, and this is negative 1,836. Okay, sure. Now let's equation E, let's make that, let's take D, and let's get rid of this right here, and we can do that by adding equation B It's 30 times? Yeah. That's equation D plus B times 30. Oh, there should be more parentheses there. That 0 plus 0, hey, that's 0. Cool. 6 times 3 is 18 times 10 is 180, so this also goes to 0. And then this 12 times, 30 is 360 less this. I have it written down right there. It's 144. And then, yeah, that's just going to be ugly. I'm going to look at my calculations. It's 324. Now that we've got that all known, we're saying that 144 times CY is equal to 324 kips in this case. So let's just call F is some constant times E, and that constant, of course, is going to be 1 over 144. Turns out that when you take 0 and divide it by 144, it stays 0. Same with 0. This becomes 1, and this becomes 2.25. So let's circle that one with a pitiful red marker and keep going. Now that we've got this all known, we can just eliminate it from this equation up here. So we can say, G is equal to, well, D, let's multiply that by a constant here, and then, add F times a constant right here. And that, right, we can just divide this value, this one, by 180, negative 180, really. That's going to stay 0. We can make this be 6. This becomes 0, and this becomes 45. Then just divide this by 6. We're going to end up with by all on its own. So G times some constant C. The constant in this case is 1/6. 0, 1, 0. 45/6 is 7.5. So BY is 7.5 kips. Very cool. Going to I. Let's take this up here. C. Let's multiply it by some C. Maybe. Nah, let's not do that yet. Let's just let's subtract H times 36. This is 216. This becomes 0 because 36 minus 1 times 36 is 0. 0 minus 0 times 36, still 0. 756 minus 7.5 times 36, that's going to be 486. Finally, J, which is going to be I times some constant C. That constant is going to be 1 over 216. So we get 1, 0, 0, and that's going to be 2.25, which is pretty relieving, right? Because, there we go, that's the good red pen. These tell us then that AY, this line, is equal to 2.25 kips, This one up here tells us that cy is equal to 2.25 kips, and this right here tells us that by, oh, y'all can't see, by is equal to 7.5 kips. So as you can see, it takes a good bit of work to determine indeterminate structures' reactions, but it is eminently possible so long as we know that our Young's modulus and our second moment of inertia are constant, or I suppose you could have them be different from A to B and from B to C, but as long as you know what they are, or know that they're constant, or know what they are relative to each other, it's absolutely possible to determine the reactions based on just integrating over and over, realistically.